This is the end of the module review. Can the table shown below represent a function and explain? The answer is yes. Each input has one output. Okay. Next. A linear function has the table of values below related to the cost of a certain tablet. Write the linear function that represents the total cost y for the number of tablets. All right. So we have 17 and 10 comma 183, and we have 22 and 13 178. So here I've got x1 y1 x2 y2. So we have 13 178 minus 10 183 over 22 minus 17. And that will equal 2995 over 5, which equals 599. So using our y equals mx plus b, and using a point, I'm going to use the first one here. So I've got 10,183 equals 599 times 17 plus b. So I have 10,183 equals 10,183 plus b. Would I subtract the two? B equals 0. So now y equals 599x, and that's my equation. So next is the rate discrete or continuous. It is discrete. You cannot use fractions or decimals to represent, tablets. What number does the function assign to 7? Well, y equals 599 times 7. So that would equal $4,193. So 7 tablets cost $4,193. Oops, sorry guys. Okay. So next. It says a linear function assigns the inputs and corresponding output shown in the table below. Is the function a linear function? Well, we've got to check our points here. So we've got -6, -6, -5, -5. So here we have -5 minus -6, -5 minus -6. So x1, y1, x2, y2. So leave change for both of these. So we have 1 over 1, which equals 1. Then we have negative 5 minus 5, and we have negative 4, negative 4. All right, so based on all of this, we have our linear function. Excuse me. Excuse me. It says, what will the graph of the linear function look like? And explain. The graph will be a line in the form y equals mx plus b. Okay. Next. Brothers Paul and Pete walk 2 miles to school from home at constant rates. Paul can walk to school in 24 minutes. Pete has slept in again and needs to run to school. Pete's speed is shown in the graph. Which brother walks at a greater rate? And explain how you know. Well, Paul can walk to school in 24 minutes. So he has 2 miles in 24 minutes. So 1/12 or 0.083 repeating. Okay. So for Pete, we can go up 8 and over 1. So he has over 8 or up 8 and over 1 to an hour here. So if we change that to 60 minutes, we have 8 over 60. Okay, and that's going to give us 2 over 15, which is going to equal 0.13 repeated. So for that, when we look at that, Pete walks at a greater rate because two over 15 is greater than 1/12. Okay. So now, next we have the graph below is the graph of a function. Do you think the function is linear or nonlinear? Show your work and explain in your explanation that supports your answer. Okay. Well, here we have our slope. First of all, we go down 2 over 1, down 2 over 1, down 2 over 1, and down 2 and over 1. So each time our slope goes down 2 and to the right 1. So we have our slope is negative 2 over 1, which equals negative 2. The function is linear because it has a constant rate of change. The graph is a line. Okay. So next it says a function for number 6. A function rule has of the rule so that each input x is assigned an output 1/2 x squared. Do you think the graph of the function will be linear or nonlinear? What shape do you expect the graph to take? And explain. It is nonlinear the exponent, the shape I would expect, well, first of all, it is nonlinear because the exponent on the x value is not a 1. The graph would be a curve. Okay. So now number 7, it says the graph below shows the relationship between a car's value and time. Match each part of the graph, A through C, to its verbal description and explain the reasoning behind your choice. Okay. So number 1, the value of the car holds steady due to a positive consumer report on the same model. This would be B, because it's holding steady. That means a zero slope. There is a shortage of used cars on the market, and the value of the car rises at a constant rate. Okay, that would be C. And that means it says a car rises at a constant rate. It says the value of a car depreciates at a constant rate. That is A. That means it's negative because it depreciates. Okay. So next, we have a car starts a journey with 18 gallons of fuel. The car will consume 0.04 gallons for every mile driven. Let A represent the amount of gas in the tank in gallons, and M represent the number of miles driven. How much gas is in the tank if 0 miles have driven? How would this be represented on the axis? Okay. Well, it says a car starts the journey with 18 gallons of fuel. So we would represent that right here. Okay. So how that would be represented, there are 18 gallons of gas. In the tank. It would be represented by 0, 18. It is the initial value. Says, what is the rate of change that relates the amount of gas in the tank to the number of miles driven? Okay, that is this right here. For every mile driven, that is our rate of change. Okay, so our rate of change is 0.04, and it's negative because we're using that miles per gallon. Okay, because the car consumes 0.04 gallons every mile driven. Oh, sorry. Next, it says on the above axes, graph the line that relates A to M. Okay, A to M. So for that, what we need to do is we need to plot a couple of points here. Okay, so what we have to do is to relate A to M, okay, oh, let me move that up. M is 0.04 over 1. And to move the decimal point over by 2, we've got to multiply top and bottom by 100, which would give us negative 4 over 100. So we would go down by 4 and to the right by 100. Okay, so here we go. So I would go down by 4 to the right by 100. Here's our 100. Okay, so I'm going to go down by 4, 1, 2, 3, 4, and go over to 100, which would be this point right here. I'm going to go down 4, 1, 2, 3, 4, and go over to 100. Go down 4, 1, 2, 3, 4, and go over to 100. Let me do that again. And I'm going to graph that line. I had that point wrong. All right. Now it says write the linear function that models the relationship. So to write the model then would be A equals negative 0.04 M plus 18. Okay. So next we have Lamar and his sister on the Ferris wheel. And we talked about this in class, guys. So nothing new. It says the graph below represents Lamar and his sister's distance above the ground with the Ferris with the ground with respect to the time during the next 40 seconds of the ride. Okay. Now it says name one interval where the function is increasing. Okay. Well, I'm going to name a few of them so that you have this on your review. Okay. Because we have between 40 and 44. Oops, sorry. 40 and 40. We have 40 and 44, 48 and 52, 56 and 60, and 72 to 76. Let's name one interval where the function is decreasing. Again, I'm going to name a few of those as well. We have 44 to 48, 52 to 56, 64 to 66, 70 to 72, 76 to 80. So is the function linear or nonlinear? It is nonlinear during all intervals. Except 60 to 64 and 66 to 70, where those sections are linear. Okay. Next, it says what could be happening during the interval of time from 60 to 64 seconds. The Ferris wheel is not moving. So riders could be getting off. Or on. It says based on the graph, how many complete revolutions are made during the 40-second time interval? Four complete revolutions. This ends the lesson.